So today we are putting together everything we have learned in Unit 6. So we need to also think today about is it a whole or is it a part, percents, how to set a proportion, and so on and so forth. So here is the first example. You are making a punch that is 40% pineapple juice and 60% orange juice. If you have a pitcher that can hold 32 ounces, how much orange juice should you put in? So we have a pitcher that would be holding both pineapple juice and orange juice. So that tells us that part of our proportion has to be 100% because 40% of that is pineapple and 60% is orange juice. So I know for sure that in my proportion I need to put 100% somewhere because that's the total. That's how much I have of punch, what percent of punch. And now I'm looking at it, says if you have a pitcher that can hold 32 ounces, so the whole pitcher, which is 100%, that would go with 32 ounces. I can put them at the same level if I want to. And then I am looking at the question, how much orange juice should you put in? So if this is 32 ounces down here, then orange juice should also be in ounces. So here I am. I put for ounces up here. I'm actually trying to find it. Now I need to fill the top here. So what percents go with 100%? It's what's related to orange juice. So I have 60% of orange juice, so that should be here. So 60% in relation to total is how many ounces in relation to total. And then we simply again just punch into calculator 32 times 60 and then divide by 100 gives us 19.2 ounces of orange juice. Keep in mind, you did not have to set it up this way. You could have also put 60%, so 60% goes with, that's both of them are parts, and then 100% would go with 32. I mean, there are 4 different ways you could set this up. The second problem that we are going to look at is related to oil-gas mixture. The engine in Kevin's power washer uses an oil-gas mixture. It takes 1/4 parts oil with 2 parts gas. And that's our first ratio. You know that for every 1/4 part of oil, you put 2 parts of gas. Kevin has a 16-ounce container of oil and plans to use all of it. So this is oil that we have, and we need to find how much gas we need to find. So 1/4 of oil, because oil goes with oil on the other side at the level. He has 16-ounce container of oil, so that should be here. Now this is ounces, so I know that my answer for the gas will be ounces as well. Whatever is 1, if we say 1/4 parts oil to 2 parts gas, that means if we are using gallons, it will be 1/4 gallon of oil to 2 gallons of gas, or in this case, ounces. So 1/4 part oil goes with 2 parts of gas. Then 16 ounces of oil goes with certain amount of ounces of gas. And then we do the cross product, 16 times 2. Now notice this, 16 times 2, we need to divide by 1/4. All right? Now keep in mind, you can do that different ways. You can actually divide 1 by 4 right away and change it to 0.25 because that's the same thing. And then you would do 16, divide by 2, multiply by 2, divide by 0.25. Or you can do 16 times 2, and dividing by 1/4 is the same as multiplying by 4, and then multiply by 4 there. Either way it will work. So 16 times 2 divided by 0.25 will give me 128 ounces of gas. Okay. And notice this has to be large amount because 1/4 parts of oil goes for every two parts of gas. So it should have a lot of gas with 16 ounces of oil. How large of a container will we need to hold the mixture? So the mixture would have to be able to the container would have to be able to hold all oil we put in and all gas we put in, which would actually be 16 ounces of oil plus 128 ounces of gas, which will give us 144 ounces container. Now, you probably would want a little bit more so it doesn't spill over. Oh, we don't need of.